polar coordinate system. Polar coordinate system. Now, if we want to locate this point, Polar says that with reference to the x-axis, if we project this point or if you draw a line from the point to the origin 0, 0 to the origin 0, 0, right, and we measure the angle it makes with the x-axis and also measure the distance, then we'll get to the point. Let me take that one again. Project or draw a line from the point to the origin, measure the angle and the distance, and we'll get to the point. So the polar coordinate is characterized by r and theta. The polar coordinate is characterized by r and theta. It's characterized by r and theta. Now let's see. If we project this point onto the y-axis, onto the x, sorry, and now this onto the y. Remember, we are calling the distance from the point to the origin r. Let me use a line to represent that. We are calling it r and the angle theta. Now, when we see the relationship between this one, and the Cartesian coordinate. Okay, from SOHCAHTOA, right? I hope you remember trigonometry. SOHCAHTOA. We can say that the x here, right, is equal to r cos theta, and y there will be equal to r sin theta. Remember, with reference to this theta, right, then with reference to this theta, then this becomes the adjacent. So if we want this distance from this one to this side, right, they will use chi, right? That is, this distance is equal to the hypotenuse times the cos of the angle, and that distance here, right, is equal to the hypotenuse times the sine of the angle. Okay, now this is the relationship between Cartesian and polar coordinate. Theta is given by the tan inverse of y over x, and x squared plus y squared is equal to r squared. This is from Pythagoras theorem. Okay, now this one they all hold, right? Now let's look at, I can clean the board, right? Good. So look at a few more. This means that if I have a point, this means that if r is 5 and theta is 30 degrees, right? Now let me use radians, okay? Let me use pi and 6. Of course, we know pi is 180 divided by 6, right? Then this is a point. This here is a point in polar coordinate. It's a point because if I want to locate that point, then I measure pi on 6 degrees with reference to the x-axis, right? And on that line, I measure 5 meters or 5 centimeters. Let's say here. Okay, so this is our point. So this is a point. Okay, now if I want to convert this point, which is in polar coordinate, to Cartesian, then I know that in Cartesian, my parameters are x and y. Now remember, we said polar, the parameters are r and theta. So here, this r is 5 and theta is pi on 6. Right, now here, the parameters in Cartesian is x and y. So once I can find my x and y component, I'm done. And we know that x is equal to r cos theta. So here it means my x will be given by r, which is 5, times the cos of the angle pi on 6. Okay, and y also be given by my r, which is 5, times the sine of the angle pi on 6. So if you're able to compute that, right, then we would have our x and y. Now let me see. Let me just compute that for us. I'm using calculator now, right? Of course, sine 30 is half, so that is 5.5 and 2.5. Sorry, let me just do that quickly. Calculator, where are you? But this should. Okay. I may be wrong. Okay, fine. Let's see. Sine theta, right? Sine this 30. Yeah, it's 30. So sine 30 is half. So y is 5 over 2. And cos 30 is root 2 on 3. So y is 5x, sorry, x let me do it here. X is equal to 5 times root 2 root 3 on 2. Okay. So my converting this one to Cartesian, right? I get 5 root 3 on 2, comma, and on 2, sorry. This is on 2, not on 6. And 5 on 2. Now, this is converting polar to Cartesian. We can also convert a point from Cartesian also to polar. From Cartesian also to polar. Okay, let's see. If I'm converting the point to 1, converting the point 1, 1 from Cartesian to polar. Okay, Cartesian to polar. Then I know that in Cartesian it's characterized by x and y. So it means x is 1, y is 1, right? And I want r and theta. The relationship between this is that now I will just need r and theta. And what is r? We know that x squared plus y squared should give me r squared. So x squared here is 1 squared is equal to 1 squared. Sorry, is equal to r squared. Now this is 2, so it means r is the root of 2. we need theta. Theta is the tan inverse of y, which is 1 over x, which is 1, so 1 over 1. Okay, and tan inverse of 1, I think it's 45 pi over 4. So this is pi over 4. So I've converted the point from polar, from Cartesian to polar. Okay, let's see. If in polar we say that r is equal to 4, what is this in polar coordinate? Now r is equal to 4. Remember, we've not been leaving theta. It's only r is equal to 4. It means that theta can take any value, right? So if I measure my distance 4 from the origin, right? Then, because theta can take any value, I can move round, and this becomes a circle. This is the same idea. Given a Cartesian coordinate x and y. If you say x is equal to 4, because I have not defined y, I just go to x, note my 4, right? And draw an infinite line. Y can take any value. So here I just move like that. Okay. In the y direction. It's the same idea. So once I've not defined theta, theta can go round and round. The theta moves this way. Can go round, and I get a circle. The same way, a circle of radius 4, I must emphasize. The same way, if we say r is theta is equal to pi on 7. Let me put it into bracket. Let me say pi on 7. It means that I come to, in polar coordinate, I come to my x, measure the angle pi on 7. And because I've not defined r, it means r will go to infinity. So I stand here and draw a line straight through. And that so it's a line that makes an angle pi on 7 with the x-axis. So we've had enough of polar coordinates. We'll look at more when we come to double integral in polar coordinates. But for now, let's move to rectangular coordinate.